everybody, this is Emily Comacher. I am presenting number 11 out of the week 10 problem set. And this number 11 had us prove the remainder theorem, and I went ahead and listed the remainder theorem down below here. But it also asks us to use the division algorithm of polynomials. And so the remainder theorem basically is talking about two polynomials, g and f, and it's saying that if f is of the form of x minus a, so f is just like a linear polynomial, when you divide that into g, or take g divided by f, that linear polynomial, then the remainder either has to be 0 or another constant. And in addition to that, not only is that true, that it's 0 or a constant, but if you were to plug this value of a into that original polynomial g of x, which was what you were dividing into, it would match that remainder. So plugging that a into g of x, it would match what the remainder is. So we're going to look at both of those things and kind of prove why that has to be true. So starting with the first part, that the remainder must be 0 or be a constant, we're going to talk about the division algorithm a little bit. And so in the division algorithm, it says that if you have your polynomials a and b, so this would be like our g and our f in this case, there are unique polynomials q and r such that b, the one that you're dividing by, can break down into a times some quotient polynomial plus the remainder, okay? And this means that the remainder is either 0, in the division algorithm, the remainder is either 0 or the degree of the remainder is less than the degree of a, which is what we're dividing by, okay? So this is really the part that tells us that the remainder has to either be 0 or a constant. Because what we're dividing by is a linear polynomial, x minus a, the only way for the degree of our remainder to be less than that would be if the degree of our remainder was 0. Which means it's either the 0 polynomial or another constant of degree 0. So I kind of stated that down below. Suppose that f and g are polynomials where f of x is that linear x minus a, and the degree of f of x is less than the degree of g of x. We said by the polynomial division algorithm, we can say that if we are to divide g by f, then it can be written as this. So g of x is made up of that f times the quotient polynomial plus some remainder, okay? And in that case, the degree of r has to be less than the degree of f according to the division algorithm. Well, since f is that linear one, the degree of r is limited to 0. So in other words, r is constant or 0 itself, okay? And then moving on to the second part of that, I'll go back to the second part, we're trying to prove that the remainder is actually, in fact, what g of a is, okay? So if we use that division algorithm, that g of x is f of x times the quotient plus r of x, g of x, or f of x, excuse me, can be replaced with that x minus a. So we've just taken that and we've replaced with what we know f of x to look like. And then substituting a in for each of these values of x, we have g of a is equal to a minus a, and that will yield 0 in the next step, times q of a plus r of a. Okay, now 0 times q of a is going to end up canceling each other out, or really eliminating itself, because anything times 0 is 0. And so we have that g of a is equal to the remainder. Okay, so this just validates that if you take that a value, which was the 0, if the factor is x minus a, when you plug that into your original g function, that should yield the remainder that you get. Okay, so that was kind of taking a look at both of those steps, and that is it.